Hi, this is Mihai, and in this video I'm going to show you how to test the coincidence board using Raspberry Pi software I wrote. So what we're going to do first, we're going to log into the Raspberry Pi. I connected the board to the Raspberry Pi already. You could see the setup on the link below. You need to place a short between C4 and C5 on the actual board for this to work. This is because the Raspberry Pi is too slow to test this board real time. You can download the software. It's called the Muon Hunter Test. You could download it from my Git account or from my website. It's going to create a directory. If you do it through Git, we can just enter the directory. This is a Python class, so you could use your Python interpreter. You need to start it in root mode though. So here we go. Because you'll have to have access to the GPIO pins. And all you do is you just import the ctest class. And then to use it you need to create a test instance. So you're going to call this test1. So the first argument of the constructor is the input pins of the GM signals. This is 18 and 22 in this case. And the coincidence signal is 23. So we created the test instance. Now what this will do, it will create all the logical possibilities and it will feed these into the circuit as inputs. So it's going to pretend that this is a Geiger signal and see how the circuit reacts. So how it responds to that. So let's say test. You can check what it will do by saying test1 for each cases. So it will run this. It will set 0, logic 0 on low on pin 18 and pin 22 first. Then logic 1 on 18 and 0 on 22, etc. To run, you say test1 run, and it ran and it was a pass. Now you could look at the log by saying test1 print log. And you can see that it does what it should do. When both the signals are low, that's when we've got a coincidence, otherwise we don't. If you've got a fail as a result of this, then you could take a look at this log and then you could localize the problem. Now this test program will run on more than 2 coincidence signals too. So if you've got 2 of these Muon Hunter kits, or you just pair up with one of your buddies and you create, let's say, a 3 or 4 coincidence setup, then you could still use the same program to evaluate that. So we are going to create a 3 coincidence setup. Coincidence 3 equals ctest, and let's pretend that this is pin 18, the current pin 22, and then we connected 24 as well. And then our coincidence signal is still pin 23. And then let's see what it will do. Oops, that's 3. Print cases. So it will test for these cases. So we're just going to run for the fun of it. Obviously it's going to be a fail since we don't have that equipment connected. 3, and then we can just have a look at the log. And we could see, yeah, that's where it failed. Our coincidence was still reported on 22 and 18 being 0, and then we got 23, 0. But 24 was a 1, so yes, that's a fail. It should be, the result should be on Monday. Because that's not a free coincidence. And you could just run the test all over again, and then if you print it out, you'll see the log for run 1, run 2, etc, etc. Now you could do the same thing for 4 coincidence. So let's see what we do in that case. You would say coincidence 4 would be a C test, and let's just add 25 as an input. Coincidence 4. Print cases. There you go. Obviously there are a lot more cases, and let's just run this one as well. And this is a fail. Coincidence 4, print log. There you go, you can see where it failed. So I hope you will like this little software, have fun using it and setting up interesting experiments. Thanks for watching, and see you next time.